All right. Another very important quantity in the universe that we're talking about is enthalpy, which has the symbol H. What enthalpy is, it's a measure of the total heat content of a system. Enthalpy is a derivative of internal energy, which has the symbol U. And internal energy is essentially just a measure of heat energy. Because this isn't a physics class or even thermodynamics like chemistry class, we're not really going to be talking that much about internal energy. That's more important, again, in physics or in physical sciences. But we will be but it is the basis of enthalpy. And the formula for this is H equals U plus PV. PV is pressure times volume, right? So since enthalpy comes from internal energy, which is a form of energy, as the name implies, conservation of energy, which is a law that we hopefully know, energy cannot be created or destroyed, just like mass cannot be created or destroyed. Conservation of energy also applies to enthalpy. What this means is that unlike entropy, in which the entropy of the universe as a whole can stay the same, or it can also increase over time. It just can't decrease. With enthalpy, or H, the total H of the universe can never change, because that would mean energy has been created or destroyed, which is not allowed. So it can't increase, it can't decrease. Enthalpy of the universe always stays the same. However, again, just like with entropy, enthalpy of a system can change as long as the enthalpy of the surroundings, so everything outside the container we're looking at, also changes. So in this case, it has to change by an equal but opposite amount. If the enthalpy of the container increases by 10, that means the enthalpy of the surroundings has to decrease by 10 in order to balance out. And this again also has an equation of enthalpy of the universe equals enthalpy of the system plus enthalpy of the surroundings. Okay, so moving on. Enthalpy is commonly used to measure the favorability of a reaction in terms of heat. So we know that for entropy, the universe always favors something that's more chaotic, more entropically favored. That would mean, for example, going from a liquid to a gas, going from a solid to a liquid, going from like a cold state to a hot state, of increasing temperatures, something like that. It favors going, essentially, mostly it favors going from a lower entropy state, so like solid, to a more entropically favored state like a gas. Okay. For enthalpy, however, enthalpy measures the favorability in terms of heat rather than randomness. For example, if a reaction has a delta H, which is just a change in enthalpy, that is negative, that means the reaction releases heat to the surroundings, which is favorable, right? We want the system to release heat into the surroundings. If the delta H of a reaction is positive, that means it had to have absorbed heat from the surroundings, which is not very favorable when we look at it, right? We want it to release, we don't want it to absorb. These are called exothermic and endothermic respectively. And you can think of it this way: exo means outside, so releasing heat outside is exothermic. Endo means inside, taking in heat from the outside to yourself, taking heat inside is endothermic. Exothermic is favorable, endothermic is not favorable in terms of heat. The units for enthalpy are joules, just like with any other form of energy. However, delta H for a chemical reaction is usually joules per mole. Just like I mentioned, when we look at chemical reactions, we usually do it on a per molar basis. Okay. And there's this thing called the delta H formation, which is what we're going to look at next. And this is the main thing that you'll be looking at when you have questions regarding enthalpy on the MCAT. So one easy way to find the enthalpy, the delta H or change in enthalpy of a chemical reaction is if you are given the delta H of formation of the reactants and the products. Okay, so if you look here, there are these water molecule. So we're turning methane plus O3, which is ozone, into CO2 and H2O, right? It's combustion. And we want to see how much energy does this reaction release, right? How much heat does this reaction release? Or I shouldn't say heat, because heat is a different thing. How much energy does this reaction release? How do we do that? Well, if we have this table right here that shows us the delta H information of each of these different components, right? So for example, if we have the delta H information of water, the delta H information of CO2, O3, and CH4, we can then find the delta H of the whole reaction, or Rxn, in the bottom. And the equation is the delta H of the reaction is the delta H formation of the products, or it's the sum of the delta H formation of the products minus the sum of the delta H formation of the reactants. So what you would do in this case is you would take the delta H formation of water, multiply it by 2, because again, this is kilojoules per mole, right? Give you in kilojoules per mole. So that means since we're using 2 moles of water, we would have to multiply whatever value this is by 2. And then you have CO2, delta H formation of that. You'd add those together and then subtract the sum of these 2 delta H's. Okay, then you would have the full delta H of the reaction. And we're actually going to do that in this next slide. So please, we're going to open a poll. Second. Okay. So we're going to open the poll. I believe Tim has the power to open polls. And we will get started, but please. And remember, no calculators on the MCAT. So try to do this on your own, just on a piece of pen and paper. Okay. I'll give you guys a couple minutes.
Mark, what are we solving for?
Oh, I'm sorry, we're solving for the delta H of the reaction. Yeah, so we're solving for the delta H of the reaction. Okay, please take another 30 seconds or so to answer the question, get your answers in, and then we'll go over it together. Okay. As a reminder, these polls are anonymous. Nobody knows what you specifically put in. Okay. Okay. Last couple of seconds, get your answers in if you haven't already. And Tim, if you want to close the poll and share the results.
All right, so yeah, I'm kind of curious if we gave you guys enough time or not, but we have, because not everyone responded, 75% said C and 25% said D. So maybe.
Oh, I realized I made a mistake on the poll. So does the poll? Yeah, there's no answer E on the poll. Right. Okay. So so since nobody picked answer A, could we relaunch the poll for another maybe 30 seconds or so? And if you want to choose answer E, please choose answer A, right? Since nobody picked answer A in the first place, right? You guys
Okay.
like that?
All right.
Yeah.
I'll just relaunch it.
Yeah, please relaunch it. Pick which answer you think is best. But if you want to choose answer E, choose answer A instead. Like put A in the poll as well, because we don't have an E in the poll. All right, there should be enough time. If you want to close the poll and
Yeah, we're getting some results. Okay, so more people got an answer, and so I'm going to close. So yeah, 70% said A, 30% said C.
okay, so that's good. Or I should say the 70% belongs to E. Okay. And so I'm actually happy because the correct answer was E. It's -945. And again, we added these numbers up and then we subtracted these numbers from them. Just the only trick is multiply water by 2. Okay.